The syllabus for midterm, we'll discuss that at the end of the session. Yeah?
Okay.
All right. Okay. So far, we've looked at the product rule when in the concepts of counting. All right. So the product rule and some cases of applications of product rule. All right. We looked at 5 examples or so, I think. So we apply the product rule when? When do we know that we can apply the product rule? When there's a procedure that can be broken down, a procedure that can be broken down in a sequence of tasks. A procedure that can be broken down in a sequence of tasks where each of the tasks can be done in N1, N2, N3, and so on ways, regardless of how the previous task was done. Okay. In that case, then total number of ways to do the entire procedure would be N1, N2, N3, N4, and so on, the product of them. All right. That is the product rule. The sum rule, now we will see at the start of this session, what are the conditions of applying the sum rule. For the sum rule, what we look for is a task that can be done in either N1 ways or N2 ways. Notice the difference. We are not breaking down the task or the procedure. We're not breaking down the procedure into a sequence of tasks. We are saying that the task can be done. The entire task can be done. The entire task can be done in either N1 ways or N2 ways, where there is nothing in common among this set of N1 ways and N2 ways. There is nothing in common. The set of N1 ways, the number of the ways that you have here in this set, has nothing in common with the set of N2 ways. If that is the scenario, then the total number of ways to do this task would be N1 plus N2. The generalized application of this would be a task that can be done in either N1 ways or N2 ways or N3 ways or N4 ways and so on until Nm. A task can be done with in either one of these sets of ways where there's nothing in common among these sets. If you have that situation, then the total number of ways that the task can be performed would be N1 plus N2 plus N3 and so on until Nm. Okay, let's look at an application of sum rule. It'll be clear, I'm sure, by then. So here, let's say you can choose a project for your thesis at the end of this program. Let's say you can do that. And for choosing that project, you have 3 lists of options. Okay, let's say you can choose a project from the computer group. You can choose a project from the computer group, which has 23 projects. You can choose a project from the communication group, which has 15 projects. And you can also choose a project from, let's say, the cryptography group, which has 19 projects. All right. So 23 projects in the computer group, 15 projects in the communication group, 19 projects in the cryptography group. All right. You can choose a project from any one of these groups, and each of these groups has these many projects respectively. And you can choose a project from each one of these lists. Okay. Also, none of the projects are common among these lists. That is, no project is on more than one list. The projects that are there in the first group, the computer group, none of those projects will be there in any of the other groups. The projects that are there in the communication group, none of those projects will be there in the other groups. The projects that are there in the cryptography group, none of the projects will be there in the other 2 groups. Right?
Miss, is this the main catch? Like no project is on the other list.
That is one of the main conditions that you must satisfy in order to apply the sum rule. All right. So first of all, see, we have the task of doing what? The task of choosing a computer project. The task of choosing a computer project. And this task, choosing a computer project, can be done in how many ways? In either 23 ways, either one of 23 ways, in either one of 23 ways, or one of 15 ways, or one of 19 ways. Where, as you can see from this sentence here, based on this sentence, none of the ways in these 3 sets are in common with each other. Yeah. So that satisfies the criteria of the sum rule, right? You have a set of N1 ways, a set of N2 ways, a set of N3 ways, where none of the set of N1 ways is the same as any of the set of N2 ways or N3 ways, and vice versa, right? In that case, the total number of ways to do the task would be what? Would be 23 plus 15 plus 19, 57. So when you apply the sum rule, the catch is both the fact that the task can be done in either one of these ways, either one of these ways, and that there's nothing in common among each of these sets of ways. All right. Why must we make sure that there's nothing in common among each of these sets of ways? Can you think about it?
Additional একটা চলে আসবে extra, there will be extra one.
Yes, exactly. Very good. Think about a project that is there in the computer group and the communication group and the cryptographic group as well. A project that will be there in all of these groups. Such a project, if you count that here in this way, the same way, you will count that project how many times? Thrice. You're counting the same project thrice there. So that is the problem. That is the reason when it comes to sum rule, you must make sure that none of the ways are in common. None of the sets of ways have any ways in common with each other. All right. This is very synonymous to the idea of counting the number of elements in the union of pairwise disjoint sets. All right. Think about pairwise disjoint sets. Let's say set A1 and set A2. Set A1 and A2, both of these are pairwise disjoint. And what do we mean by pairwise disjoint? There's nothing in common among these two sets. The elements in A1, none of the elements of A1 are the same as any of the elements in in A2. All right. So if you have two sets A1 and A2, and there are no elements in common among these two sets, we call them pairwise disjoint. And for such two sets, if you want to find out the number of elements in the union, in that case, how can you do it? Think about it a little bit and give me just a couple of seconds. I'll be back in a couple of seconds. Sorry, guys. So yeah, let's get back to the session. Yeah. So if you think about such two sets, can you guys tell me, is it okay to count the number of elements in such a union by counting the number of elements in the first set A1 and counting the number of elements in the second set A2 and then adding them up? Is that okay? Can you hear me, guys?
Ma'am, could you repeat the question again?
So my question was, if we have two pairwise disjoint sets, A1 and A2, where none of the elements obviously are in common among these two sets since they're pairwise disjoint, if we have such two sets, A1, A2, and we are trying to count the number of elements in the union of these sets, the union of these two sets, trying to count the number of elements. If we do that by counting the number of elements in A1 and counting the number of elements in A2 and summing that up, will we not have the number of elements in the union?
Yes, ma'am, we will have.
Yes.
Yeah, that is, we can do that, right? Why? Because the two sets are pairwise disjoint. If the two sets are pairwise disjoint, we can do something like that. The idea of the sum rule is the exact same thing. So if you have any number of sets like that, we talked about A1, A2, right? Instead of A1, A2, if you have A1, A2, A3, A4, so on until AM, and all of these sets are pairwise disjoint, all right? All of the sets must be pairwise disjoint, obviously. And if we want to count the number of elements in the union of all of these sets, we can do that by counting the number of elements in each of these sets individually and then summing that count up, all right? Summing up the number of elements in A1, A2, A3, A4, and so on until AM individually, and yeah, adding that together. We can do that, right? Does this make sense?
Yes, ma'am.
Yes.
And now if you think about it, this is very synonymous to the idea of a sum rule. Let's say A1, A2, A3, A4, and so on until AM. Each of these sets are the sets of ways in which you can do a task. You can do a task in either one of the ways in A1 or in one of the ways in A2 or in one of the ways in A3 and so on until AM. That is each of these sets as elements. প্রত্যেকটা সেটের মধ্যে এলিমেন্ট হিসেবে কি আছে? এলিমেন্ট হিসেবে আছে the number of ways you can do the task. A1 has a certain number of ways you can do the task. A2 has a certain set of ways. A2 is the set of ways you can do the task in 2 ways and so on. All right. So if each of these sets contains the number of ways you can do the task, in that case, what does the sum rule tell us? How many ways are there to do the entire task? How many ways are there to do the entire task? The union of all of these sets, and that is basically counting the elements in each of these sets individually. That is counting the number of ways individually and summing it up. Just the same idea as sum rule. Okay. This is the idea of sum rule. Actually, this is where it originates from. Relating this, we get to the sum rule. Okay. So very synonymous if you think about it. Okay. So far, we've already looked at applications of the product rule in the last sessions, and we've looked at how to spot problems where you can apply the product rule. Here we've looked at an example of the sum rule, which is very straightforward. However, in the exam, obviously you will not get a simple problem like this, where 1, 2, 3, you're done with the problem already. All right. Because you won't get something so straightforward. You won't get a straightforward problem where it's very obvious that you have to apply the sum rule, or a straightforward problem where it's obvious that you have to apply the product rule. You would get problems like this one, this problem here, where it's a little more complex, where you have to apply a combination of rules. And as many rules as you study, as you keep going on, the problems will comprise all of those rules. All right. So here, for example, for this problem, we have to apply a combination of sum rule and product rule. It won't do to apply just one of the rules. You'll see that. Okay. Let's read the problem first of all. So in a system which can have a password which can be 6 to 8 characters long. That is, the system may have a password that is either 6 character long or 7 character long or 8 character long. And where each of the characters in the password is an uppercase letter or a digit. And on top of that, each password must contain at least 1 digit as a character. If these are the conditions, then we have to find out how many possible passwords are there to satisfy these conditions. Okay. So in order to find that out, first see that the passwords can be 6 to 8 characters long, right? So if you were a user of the system and you were to choose a password, you could choose either a 6 character long password or a 7 character long password or 8 character long password, right? So basically,
Yes,
the task of creating a password following the rules, the task of creating a password can be done in either this way, that is the set of ways where you have 6 character long passwords, or the set of ways where you have 7 character long passwords, or the set of ways where you have 8 character long password. And also we cannot have a password that is both 6 and 7 characters long at the same time. Can we?
No, miss.
We cannot have a password which is both 7 and 8 characters long at the same time, or 6 and 8 characters long at the same time. Can we? No. So obviously they are pairwise disjoint. That is, the number of passwords that you will have, which are 6 characters long, obviously will be different from the number of passwords you will have that are 7 characters long or 8 characters long. Why? Simply because they are of different length. Obviously they are going to be different. So each of these sets of passwords are different from each other. All right. And you can do the task of choosing a password by either creating a 6 character long password or a 7 character long password or 8 character long password. So you have a task which you can do in either one of 3 sets of ways where there's nothing in common among these 3 sets. Can we not apply the sum rule here?
Yes, miss.
Yes,
Can
miss.
apply the sum rule. If you think about the number of passwords that are 6 characters long, let's represent that using P6. The number of passwords that are 7 characters long, let's denote that with P7. And for 8 character long passwords, let's denote that PA. In that case, the total number of possible passwords would be equivalent to the summation of these 3. The set of 6-character long passwords, a set of 7-character long passwords, a set of 8-character long passwords. All right. So far, does it make sense, guys?
Yes, miss.
Yes.
Yes, ma'am.
Now what we will do is we will find each of these values separately. That is, how many possible passwords are there which are 6 characters long exactly? How many possible passwords are there which are 7 characters long exactly? And for 8 as well. Okay. We'll next do that. Okay. Now let's just first consider the P6 case. All right. The passwords which are 6 characters long. Let's consider that scenario. Now for passwords which fall under this group, which are 6 characters long, that is, there first let's tackle this condition. Let's tackle this condition. For the 6-character long passwords, we have this condition first of all, where each character is an uppercase letter or a digit. How many uppercase English letters are there, guys?
26.
Correct. And the number of digits?
0 to 9 means 10.
10, exactly.
10.
So if we just think about the passwords where each character is an uppercase letter or a digit, just think about that. Just think about that. Forget about the rest of it. A 6-character long password where each character can be an uppercase letter or a digit. So think about it. Constructing a 6-character long password, can we not break down this entire task into 6 smaller tasks? What will be the first task? The first task will be choosing a character for the first position. The second task will be choosing the second character. The third task choosing the third character, and so on until the 6th task, which is choosing the 6th character. Can we not break down this task of constructing a 6-character long password into a sequence of 6 tasks where each task is choosing a character? The first task is choosing the first character, the second task is choosing the second character, the third task is choosing the third character, and so on until the 6th character. Does it make sense so far? Can we not
Yes,
break it down that way and we'll get the number of passwords? Yeah, okay. So now let's find out for each of these tasks, how many ways are there? How many ways are there to do the first task? What is the first task? Choosing the first character, right? If
Yes,
each
ma'am.
of the characters can be uppercase letter or a digit, for the first character, how many options do we have? It can either be an uppercase letter or a digit. So 36, exactly. 26 plus 10, 36. We have in total 36 options to choose from for the first character. That is, we have 26 ways to do the first task. Now, sorry, 36. We have 36 options to choose the first character. That is 36 ways to do the first task. Now, for each of these ways to do the first task, that is for each of this choice of character, how many options do you have for the second character? 36 again.
Yes, miss.
Yes, miss.
For the third as well, for each of the choices that you have in second, for each of them, you would have 36 as well for the third character. Same goes for fourth, fifth, and sixth, all of them. When I say each, for each of the first first character choice, you have 36 choices for the second one. What do I mean by that? Think about it. 36 choices. If you choose A, for A, you have 36 options for the second one. If you choose B, for B, again, you have 36 options for the second one. If you choose C, again, you have 36 options. If you pick 1, you have 36 options for the second one. If you pick 2, you have 36 options. Whichever option you pick for the first character, for each one of them, for every single one of those choice, you have 36 options for the second one. And for every single one of the choice for the second character, you have 36 options for the third one, and so on. So basically, it fits the scenario where we can apply the product rule. So if you just think about this condition, just only this condition, if you focus on only this condition, in that case, the total number of passwords that are 6 characters long and where each character is an uppercase letter or a digit, in that case, we can break down the task into 6 tasks where each of them can be done in 36 ways, regardless of the choice you made in the previous task. Okay? Each of them can be done in 36 ways. So can we not apply the product rule here to find out the number of ways to construct passwords that are 6 characters long?
Yes, miss.
Yes. So what would we get there? 36 multiplied by 36 multiplied by 36 and so on until
36 to the power of 6.
Exactly. 36 to the power of 6. 36 to the power of 6 is the total number of 6 character long passwords that have either an uppercase letter or a digit for each character. Okay. However, It's not so simple here. Why? Because when we do 36 to the power of 6, we are also counting those passwords which possibly do not have any digits at all, right? AJ 836 number tar moddhe to those combinations are there as well, where the password does not contain any digit at all, right? The entire password is constructed using just uppercase letters. We are counting these passwords as well, right?
Yes, miss.
Yes, ma'am.
However, the next condition tells us that each password must contain at least one digit. Each password must contain at least one digit. What does that mean? প্রত্যেকটা password at least একটা digit থাকবে মানে কি? It means that you
At least
cannot
one,
have any password. You can have no such password where all of the characters are uppercase letters, or you cannot have any password, any such passwords where where none of the characters are digits. This is what it means, right? Each password must contain at least one digit mane ki. You cannot have such a password. You cannot have such a password where all characters are uppercase. All of them, all 6 of them are uppercase letters. Or in other words, you cannot have such a password where none of the 6 characters, is a digit. Right? Does it make sense?
yes, miss.
Yes,
Okay.
miss.
However, we have counted them as well when we were doing 336 to the power of 6. Now, instead of directly counting the passwords where you have uppercase letter or a digit for each character and at least one is a digit. Instead of doing something like that directly, that idea is complex, all right? Because how do you do that directly? That gets a bit complex. The simpler way is just to count all the passwords that have either an uppercase letter or a digit for all 6 characters, and from there deduct or get rid of all the passwords which have no digits in them. Okay? So in the first count, the 36 to the power of 6, we also counted those passwords which have no digits in them, right? However, the next condition said that we can never have such a password which has no digit in it, all right? We cannot have a password where there are no digits. That is, we cannot have such a password where all of the characters are uppercase letters. So we can just simply get rid of those combinations and we will have a password that satisfies all the conditions. Tell me now, what will be the total count of passwords which contain no digits? That is, what will be the total count of passwords where all 6 characters are uppercase letters?
26 to the power
Miss
6.
26
Exactly, 26 to the power of 6. Correct. 26 to the power of 6. So that is, instead of calculating P6 directly, if we calculate it by first finding out the number of passwords where you have either an uppercase letter or digit for all 6 characters, including those with no digits, and from that we subtract all the passwords which have no digits in them. So this 36 to the power of 6, that count 36 to the power of 6 includes those passwords which do not have any digits. ওখান থেকে simply just get rid of those passwords which do not contain any digits, and that is something that can be done very easily. That is a lot easier to approach, all right? 36 to the power of 6 minus 26 to the power of 6. 26 to the power of 6 is the number of all those passwords which do not have any digits, and 36 to the power of 6 includes this number, so just get rid of that. And then you will have that number of passwords where you have each of the 6 characters are up as uppercase or uppercase English letter or digit, and at least one is a digit, all right? So you have a number of passwords that follows all the conditions. So that's for P6. Can you guys tell me how we would calculate the passwords which are 7 characters long?
Miss 36 to the power 7 minus 26 to the power 7.
Exactly, correct. And for P8?
Miss same 36 to the power 8 minus 26 to the power 8.
Exactly. It's just the character's length that changes, but the approach of the problem remains the same, all right? See again here why it's very important to identify similarities between problems. You solved one problem and the other ones followed the same solution, all right? you can apply that in massive scale as well. So that is the reason it's very important to understand or identify the similarities between problems. So yeah, so P6, P7, and P8 can be calculated as such. And finally, the total number of passwords which follow all the conditions would be what? The summation of all of these numbers, and that will give you the value of P. Any questions regarding this problem?
No, miss.
That's good for me then. However, if you have any confusion or question at any point, you can obviously ask, and you should ask, because you should know how to solve problems where you have to apply both product rule and sum rule, and you have to figure out when to apply the sum rule and when to apply the product rule and how so. Right? So if you don't understand any part of this problem, then you sure as hell won't be able to solve problems where you have to apply a combination of multiple rules and you have to find out where to apply which one.
Miss.
Yeah.
Can I ask a question?
Yeah, sure.
Can you go to the next slide?
Yeah.
Miss, if it said each password must contain at least 2 digits, then it would have been more complicated, right?
Each of them must contain at least 2 digits. Yeah, it would be a lot more complicated then. Yeah, if it said something like that at least 2 digits, in that case, yeah, it would be a lot more complex. Yeah.
Yes, yes.
Miss, if the question was at least 1 digit and at least 1 uppercase letter, then what we should have done?
That one is quite straightforward. What do you guys think?
Then
Quite
we need to subtract the digits as well. 10 to the power 6.
We need to subtract the number of possible passwords that contain only digits, right? Yeah, you're correct. That is 36 to the power 6 minus 20 to the power 6, then minus 10 to the power 6. Yes, that is correct. Because you just added another condition, right? As simple as that. So yeah, you're correct. Okay. So let's do another problem which combines the two rules and then counts the total number of results. So here we have a version of basic where a variable name can be a string of 1 or 2 alphanumeric characters. That is, a variable name can be 1 character long or 2 character long, and where the characters are alphanumeric characters. What are alphanumeric characters? Alphanumeric characters are those characters which are either one of the 26 English letters or 10 digits. The set of alphanumeric characters consists of all the 26 English letter and the 10 digits. Okay, and also, by the way, we do not differentiate between uppercase and lowercase in case of alphanumerics. All right, in case of alphanumerics, lowercase a, uppercase a, they're the same thing. All right. So we have a version of basic where a variable can be either 1 character long or 2 characters long, and where each character is an alphanumeric character. And an alphanumeric character is what? Is a character that can be either one of the 26 English letters or one of the 10 digits. Okay, so 36 options for alphanumeric characters basically. On top of that, a variable in this version of basic, a variable name starts with a letter, begins with a letter. That is, in a variable name, the first character will always be a letter. Okay, and also there are 5 strings which are reserved for programming use. 5 fixed strings which are reserved for programming use, which makes sense. If you've done even basic programming, you know that there are some names which are reserved for programming purposes. For example, for, if, these key terms, these are reserved for programming use. So similarly, in this version of basic, there are 5 strings of 2 characters, 5 strings of 2 characters which are reserved for programming use. You cannot use these as your variable name. Okay, so if these are the conditions, we have to find out, we have to count the number of different variable names in this version of basic. All right. So first, let's look at this part here. the name of the variable can either be 1 character long or 2 character long. That is, you can either have a, that is, in order to construct a variable, you can either have a variable that is 1 character long or 2 character long. Let's say the total number of variables, the total number of variable names is v, okay? And the total number of variables which are 1 character long is v1. The total number of variables which are 2 character long is v2. If you were to choose a variable name in BASIC, in this version of BASIC, in that case, if you were to choose a variable name, you could either choose one of the 1 character long variables or one of the 2 character long variables, where none of the sets contain any variable name in common among the two, right? v1 representing that all those variables which are 1 character long, v2 representing all those variables which are 2 character long. And is there anything going to be common among these two sets? No. They're of 2 different lengths, right? Length is different. So the number of variables you will have in v1, which are 1 character long, none of them will be the same as the number of variables you have in v2, which are 2 characters long. Length is different, so obviously the variables are going to be different, each one of them in these 2 sets. However, when you want to choose a variable, you can either choose one from v1 or one from v2, okay? So if v1 is all those variables which are 1 character long and v2 is all those variables which are 2 character long, can we not say that the total number of variables v would be equivalent to v1 plus v2?
Yes, Max.
Okay, so that part is pretty easy. So yeah, okay, done. Now next, we have to find out, just like the previous example, we have to find out v1 and v2 individually. v1 is quite straightforward. v1 is quite easy and simple. Why is that? Because v1 contains all those variable names.
36, right?
36. Okay. Okay. All right. That's a possibility. Let's talk about that first. But why do you think it's 36? Because
Only
it's 1
V1.
character long, right? v1, only 1 character long. That's why you're thinking it's going to be 36, right?
No, only
v1. I'm talking about v1. Yes. v1 is only 1 character long. Because it's 1 character long, you're saying 36, right? Okay. No need to be so scared to respond back to a question, right?
now.
Yeah, okay. Okay. So, okay, in that case, just before answering the question, whether it's going to be 36 or not, let's see what we will indeed have for v1. First of all, v1 contains all those variables which are 1 character long. Is this part clear?
yes, Max.
Yes, yes.
Okay. If v1 can contain only 1 character, if v1 can contain only 1 character, and we know that in this version of BASIC, a variable name must begin with a letter. A variable name must begin with a letter. That is the first character. The first character in a variable name must be a letter.
Miss 26
So
then.
combine the two. 26, exactly. The total number of letters is 26. v1 is all those variables. v1 contains all those variables which are 1 character long. If you have just 1 character long, if you just have 1 character, then first character ta to letter hobe, and that's it, done. First character ta jeta, first ektai to character ache. And the first character, as they said here, must be a letter. So for v1, how many options do you have? 26. Because there's just 1 character, and that 1 character will be the first character, obviously, ektai character, and that must be a letter. And how many letters are there? 26. So v1 will be 26. 1 character variable name must be a letter, since they said that variable names must begin with a letter. Is this clear? That v1 will be 26. Does it make
Yes,
sense,
ma'am.
guys? Yeah,
Yes,
okay.
miss.
That's right.
Right. Now let's talk about v2. v2 khetre, it's a little bit complicated, right? v2 khetre, first of all, it's 2 characters long. Since it's 2 characters long, it's not going to be the same straightforward as v1. v2, for the task of finding a variable name or choosing a variable name that is 2 characters long. This is the task we have. That is, right? Choosing a variable name which is 2 characters long. For V2, this is the task we have. This task, can we not break it down to 2 smaller tasks of choosing the first character and then choosing the second character?
Yes, miss.
Okay, if you break it down to smaller tasks, let's see each of these tasks. How many ways are there to do each of these tasks? The first task, which is choosing the first character. For the first character, how many options do we have? Remember, a variable name must begin with a letter. So the
Yes,
first
26.
character. Sorry?
26.
26, exactly. We have 26 options for the first character. And for each of these options, how many options do we have for the second task? The second task is choosing the second character. Now, for the second character, there are no restrictions. The second character can be any one of the alphanumeric characters. Any one of the
36.
alphanumeric characters. So in
36.
that case, 36 options, exactly. So for the first task, we have 26 options. For the second task, we have 36 options. All right. And for each of the 26 ways, to do the first task, that is for each of the 26 options of choosing the first character, we have 36 options to choose the second character. All right. So the total number of variables that are 2 character long, where the first character is a letter and the second character is an alphanumeric character, such variables, the total number of such variables would be 26 multiplied with 36. All right. However, we're not done yet. Why? Because we must not count the 5 strings, which are reserved for programming use. Now, since this is for programming use, it's safe to assume that these 5 strings remain fixed. That is, these 5 strings obviously are not variables themselves. That is a পাঁচটা string. পাঁচটা string আছে and they will be fixed there. A পাঁচটা string fixed, let's say for, if, while, similarly, এরকম হচ্ছে গিয়ে 2 character long variable name in this version of BASIC, 2 character long, 5 strings which are 2 character long. We can say that these 5 strings will have fixed value, right? Fixed values or fixed, this will be fixed strings basically. And
Miss.
Yeah.
এটা বুঝতে পারতেছি না 5 strings 2 character long 2 character long এটা কি
2 character long হচ্ছে কি একটা variable name. So V2 এর কথা যে বলছি, all these variables are 2 characters long, right?
Yes, miss.
So 2 character long, 5টা variable name cannot be chosen. All right. 5টা variable name, I shouldn't use the word term variable name. No, 5 strings. 5টা string আছে which are 2 characters long, following all the previous rules that are there. A basic হচ্ছে গিয়ে 5টা string reserve করা for programming use. All right. So like I said, for basic programming, think about the for loop. For loop কি for keyword টা use করা হয় না, right?
Yes,
For keyword always means that you're starting a for loop. If keyword means that you're using a conditional. While keyword says that you're starting the while loop, right? So if, for, while, can you use these terms as variable names? কোন একটা variable এর নাম কি for দিতে পারবা?
no.
No, you cannot, because these terms are reserved for programming use. Similarly, they're saying that in this version of BASIC, there are 5 strings. 5টা string আছে. Each of these strings are 2 characters long, and a 5টা fixed string are reserved for programming use. 5টা কোনো string আছে, let's say MM, AA, BB, CC, something like that, whatever. All right. 5টা string আছে, which each of these are 2 characters long, which are reserved for programming use. And we cannot use them as variable names. And if we cannot use them as variable names, we just simply have to do what? Deduct them from our count of V2. V2 counts what? V2 counts all the possible variables, all the possible basic variables which are 2 characters long. All right. And from there, and that includes these 5 strings. However, there are 5 fixed strings which cannot be counted. So simply কি করব? Just simply আমাদের এই কাউন্টটা থেকে 5 deduct করব. The 5 strings. They're going to be fixed, right? Programming user জন্য. For তো forই. For এর নাম তো আরেকটা কেসে যা চেঞ্জ হয়ে যাবে না. If তো if. If is not going to be changed into if what? For is not going to be changed to for what or something like that. নাম এই term গুলো তো fixed. So those 5 fixed strings, if you just deduct that from this count As simple as that, you will get V2, right? So the total number of such variables in this version of BASIC would be V1 plus V2. Does it make sense? If it doesn't make sense, ask now. Yeah.
Is V2 there? I'm just confused. Why are we reducing 5? Because shouldn't we have my deduce it from V? Because we can have
Isn't it the same
letter.
thing?
V1 এ তো আমার থাকবে একই জিনিস, হ্যাঁ, V থেকে মাইনাস করলে একই আসবে।
Oh,
First of all, it's the same thing. And secondly, even if you think about it, V2 is the number of variables which are 2 characters long. And each of these 5 strings are 2 characters long. A pasta string, by definition, the V1, they won't even belong there. V1 is all of those variables which are 1 character long. Each of these 5 strings reserved for programming used are 2 characters long. We are counting 2 character long variable names where? In V2. So that's why we deduct it from V2.
Miss, I have a question.
Yeah.
Miss, it says 5 strings. So like 5 strings, so যে কোনো দুইটা combination we don't know how many combinations.
No. এটাই তো বলছি যে 5 string যে কোনো দুটো কম্বিনেশনে হবে না। 5টা string তো 5টা string, right?
হ্যাঁ মিস।
So মানে 5 string তুমি একটা একটা প্রোগ্রামিং ল্যাঙ্গুয়েজে তুমি বললা যে এই 5টা string হচ্ছে রিজার্ভ ফর প্রোগ্রামিং ইউজ, অলরাইট? আজকে এটা বললা, কালকে গিয়ে কি ওই 5টা string চেঞ্জ করে দিবা? No, obviously you will not do that. Since it says for programming use, it's safe to assume that these 5 strings, the value of these 5 strings will remain fixed. It will be the same. For the same programming language, এই 5টা string তো always same থাকবে. It's not going to be like এই 5টা string হচ্ছে যে কোনো ভেরিয়েবল হতে পারে।
Alright? মানে আমার if এই থাকবে, আমি চেঞ্জ করে দিব না, ওইরকমই থাকবে।
Exactly, it's like that.
Okay.
Yeah. Because they are reserved for programming use, right? So what does that mean? That a pasta string, whichever strings you choose for these 5, once you choose them, they will remain fixed. So just simply ওই 5টা হচ্ছে গিয়ে আমাদের আগের কাউন্ট থেকে বাদ দিলেই তো হয়ে যাচ্ছে, we'll get V2, right? Any other questions or confusions or observations regarding this problem?
No, miss.
All right then. So if you understand this, wouldn't you be able to do the same problem if, let's say, I ask you to find out the total number of variable names in the same scenario where the length of a variable name can be 1 character, 2 character, 3 character, and so on until the summation of all the digits in your ID. If I said something like that, wouldn't you be able to do that? Let's say here, they said that a variable name can be either 1 character long or 2 character long, right? So keeping the rest of it same, what if I told you to count all the possible variable names for the same condition where the variable name can be either 1 character long or 2 character long or 3 character long or 4 character long and so on until the summation of the digits in your ID. If I set an arbitrary limit like that, in that case, you should be able to solve the same problem then, right? Right, guys?
Yes, we have to add a lot of things.
Yeah, you have to add a lot of things, but I can tell you something to save your time. For example, here, the moment you do P6 is equal to 36 to the power of 6 minus 26 to the power of 6. A part porjonto ashle, that is enough for me. Why? Because this is not calculation 101, all right? This is not something like that. This is here, this is discrete mathematics. Here, I want to see that you know that you have to apply the product rule to calculate this and here, and then you have to deduct this from this. The logic, this part here, this logic, if you write down this logic and this logics, these things, then I know that you know how to apply the product rule and the sum rule to solve this problem. I am not interested in finding out if you can calculate 36 to the power of 6 correctly. 36 to the power of 6 is equal to what? Eta thik ache kina? I won't bother to check it. 26 to the power of 6 is equal to this. Eta ki thik ache? Calculator e boshe I won't bother to check it. That is not my concern. It is shown here just to demonstrate this to you. You have how it's done and everything. But that is not my concern. I'm not concerned about how you're going to calculate these two and how you're going to deduct this number from this number. A calculation, I'm not concerned. What do I want to see? I want to see that you're able to apply the sum rule and the product rule to solve this problem. And the moment you get here, 36 to the power of 6 minus 20 to the power of 6. By then I know that, okay, this person knows. P7 is equal to 36 to the power of 6 minus 26 to the power of 7. That is enough for me to know that, okay, you know how to apply it. And then P equals to the summation of these three. But each of these numbers individually, যে এই নাম্বারের সাথে এই নাম্বারের সাথে এই নাম্বার অ্যাড করে যে এই টোটাল নাম্বারটা পাওয়া যায়, এটা কি কারেক্ট হয়েছে কিনা, এটা I'm not concerned about that. That is not my problem. All right? I don't need to see that basically. You should be able to calculate that, but I don't need to see that. All right? That is basically, even if you don't have a calculator, you should be able to solve these problems. Okay? So same goes for this one as well. AJ, 26 multiplied by 36 minus 5 equals to কত হয়? I don't need to know that answer. All right? As long as you do say that 26 multiplied by 36 minus 5, এই যে এতটুকু পর্যন্ত আমি যখন এটা দেখব 26 multiplied by 36 minus 5 along with the given explanationটার সাথে যখন এটা থাকবে, এটা দেখলে আমি বুঝবো যে okay, you know how to apply the basic concepts of counting in order to solve this problem. I don't need to get to the number 931. All right? So say for example, if you were asked to do what I just said, calculate the total number of variables, which can be either 1 character long or 2 characters long or 3 characters long and so on until the sum of all the digits in your ID. In that case, what would you have to do? In that case, প্রত্যেকটার জন্য হ্যাঁ একটা summation তোমাকে দেখাতে হবে, but let's say the sum of your digits give you the number 40. তোমাকে v1 plus v2 plus v3 plus v4 plus v5 এভাবে করে প্রত্যেকটা লিখতে হবে? No. Understand all that we have done so far. এরকম যখন একটা certain series থাকে বা একটা sequence থাকে বা একটা format থাকে, তখন আমরা কি করি? We write the first couple of cases, that is, let's say v1 plus v2 plus v3 plus ... until what? v40. All right? Even say ... plus v39 plus v40. All right? So এরকম একটা general case তো আমরা এইভাবেই represent করি, right? When we have a general case, how do we represent it? For example, here n1 n2 until nm, এখানে কি প্রত্যেকটা number of ways এখানে list করা হয়েছে? No. n1 n2 and then ... it is assumed that এর মাঝে হচ্ছে গিয়ে n3 n4 n5 and so on until nm আছে, right? So similarly, applying those ideas, you can easily solve these problems and represent them within a short amount of time in the exam as well. I'm not going to say any more than that. Already at this point, you are a lot wiser compared to your peers from the last semester, all right? At this point of the semester, okay? They didn't know what hit them when they had the ID-based questions. At least you know what sort of questions you can expect, okay? So keep these things in mind, and whenever you see problems like this, think whether it can have arbitrary solutions or and arbitrary questions or not. So hopefully you would be able to solve such problems on counting or any other topic as well if there were questions based on ID, or if there were questions basically where there are unique questions and unique solutions for each one of you. Okay, hopefully you'll be able to do that for any concept now. Okay, now moving on to subtraction rule. The subtraction rule, we use this rule. Why? Because of that one restriction on the sum rule. Okay? That one restriction on the sum rule, which said that if you can do a task in either n1 ways or n2 ways, and there is nothing in common among these two sets of ways, none of the n1 ways is the same as any of the n2 ways. Because of this condition, we have the subtraction rule. That is, the sum rule can only be applied when a task can be done in either one of these two sets of ways, and on top of that, when there is nothing in common among these two sets of ways. However, what if there are some ways which are common among these two sets? What if that were the scenario? That is, here we said that all of these sets are pairwise disjoint, right? What if they weren't pairwise disjoint? What if they were not pairwise disjoint? Think about it.
Minus them.
Yeah, why? Because if they are not pairwise disjoint, in that case, if you count it in this way, sum rule apply kore jodi erporeo, even if they are not pairwise disjoint, if you still apply the sum rule, what are you doing? The common elements in the sets, aren't you counting them twice or more than once, basically?
Yes, miss.
You're counting the common elements more than once. So if a task can be done in either one of two sets of ways, can perform the task in either in any one of n1 ways or in any one of n2 ways. However, in this case, some of the n1 ways to do it are the same as some of the n2 ways to do it. If there are some ways among these two sets which are common, in that case, we have to subtract the common ones at least once. Why is that? Because if you apply the sum rule here, to calculate the total number of ways to do the task, and you do n1 plus n2, what are you doing? You're counting the common ways to do the task twice, right? For example, here, in this example, if there are some projects which are there in all of the lists or in multiple lists, if you have certain projects which are there in multiple lists, and if you still apply the sum rule, what are you doing? You're counting the projects which are common more than once. So because of this, what we do is, for a task that can be done either in any one of n1 ways or in any one of n2 ways, and there are some of the ways in common among these two, what we do is we sum up the number of ways in n1 and the number of ways in n2. We sum up that and deduct from it, subtract the number of ways which are common among the two. Okay. So when you add n1 and n2, when you do n1 plus n2, what are you doing? You're counting the common ways twice, ekbar n1 and then again in n2. If you're adding them, you're counting the common cases twice. So if you subtract it once, then you can get to the correct answer. All right. So to correctly count the number of ways to do such a task, we will add the n1 and n2 ways and then subtract the number of ways to do the task that are both in the set of n1 ways and in the set of n2 ways. That is the principle of inclusion, exclusion. That is the principle of inclusion, exclusion, or in other words, the subtraction principle for counting. Subtraction principle for counting or principle of inclusion, exclusion. Now, the subtraction principle for counting is synonymous with the inclusion, exclusion principle of set. Remember the inclusion, exclusion principle of set that you came across in the quiz? It was explained in the quiz, right? So this is synonymous with the inclusion, exclusion principle of two sets. Okay. What does it say? The inclusion, exclusion principle of two sets. For two sets, A and B, two finite sets A and B, which are also not pairwise disjoint. That is, there are some elements, there might be some elements that are in common among these two sets. These two sets might have some elements which are common among them. All right. In that case, if you were asked to count the number of elements in the union of these sets, in that case, you would have to count the number of elements in A and then the number of elements in B and add them up. And from this summation, you'd have to deduct the number of elements that are there in common among the two sets. Why? Because when you're doing this addition, you're counting the common elements twice, once here and again here. You're counting the common elements twice. So if you deduct it once, you get the correct answer. Okay. So this is the inclusion, exclusion principle of two sets. Does the inclusion, exclusion principle of two sets, does that one make sense? This fact that in order to count the elements in the union of two sets, which are not pairwise disjoint, you'd have to do it in this way. Does it make sense?
Yes, miss.
Okay,
Yes,
so
ma'am.
this idea is very synonymous to the subtraction principle, right? So here you're trying to count all the number of ways to do the task, all the number of ways to do the task. In order to count all the number of ways, union, right? So all the number of ways to do the task. In order to count that, you'd have to count the n1 ways to do the task, the n2 ways to do the task, and from that, you'd have to subtract all the common ways that are there in both sets, okay? So if A contains, if for A, in the set A, you have as the elements of set A, if you have all of the ways in the n1 different ways to do the task, and in B, if you have all the n2 different ways. If in A, you have all the n1 different ways, and in B, if you have all the n2 different ways, and you count the elements in A and the elements in B, then you also have to deduct the common ones because you're counting the common ones twice here in the summation. So you deduct it once. All right. Now to prove that the principle of inclusion, exclusion actually holds, to prove this, this is a logical proof of this principle in this principle for two sets. All right. So how do we prove this? First, let's assume that n1 represents the number of elements in this set. N1 represents the number of elements in this set, A minus B or A difference B. What are the elements we will have in this set, guys? A difference B. What elements will we have here? What is
The
the difference?
intersection. The intersection.
Intersection. A difference B is equivalent to intersection.
No.
Miss,
No, the values
A
of A,
is B
the elements of
B
A that are not in B.
Come again?
The elements of A that are not in B.
Exactly, as simple as that. All right. All the elements of A that are not in B will be in this set. All those elements of A which are not in B. That is, from the elements of A, we will get rid of those elements which are also in B. Those are the elements we will have in this set, right? In this set, right? Make sense?
Yes, yes.
So let's say the number of elements in this set is n1. And let's say the number of elements in the set that is the intersection between A and B is n2. What will we have in the intersection set, guys? In A,
The common elements.
Elements that are common in both A and B.
yes, the common elements between A and B will be here in this set. And let's say n2 represents all the elements, or the number of elements. N2 represents the number of elements in this set. And similarly, n3 contains the number of elements in the set which has all the elements of B that are not in A. All those elements of B that are not in A. So from the elements of B, you drop those elements which are there in common among these two sets. All those elements of B which are not there in A. Okay. So far, is it clear?
Yes.
Yes.
Okay. Now, if we have to count the number of elements in A, if we are asked to count the number of elements of A, can we not do that by summing up n1 and n2? Why? Because in n1, you have all those elements of A which are not in B. That is, from all the elements of A, you dropped those elements which are in common among the two sets, right? In this case, for n1, you have a
Yes,
set
ma'am.
where you have all those elements of A which are not in common with B. So from all the elements of A, you dropped the common elements between these two sets. So along with this, if you add the count for those elements which are in common among the two, you will get A, right? You will get the correct count of A. Here, you're dropping the elements which are in common, and here, you're counting the elements which are in common. So adding these two, we will get the total count of A. Does it make sense?
Yes, miss.
Okay. Similarly, we can get the total count of B by adding n2 and n3. In n3, we have all those elements of B which are not in A. That is, from the elements of B, we drop the common elements. All right. So, and n2 counts the common elements. So n2 plus n3 gives the total count of the elements in B. Right. Now, A union B, the elements in this set, in the union set, would be what? Would be the elements that are there in A but not in B. That is, only those elements of A which are not in common with the other set, only those elements of B which are not in common with the other set. Here, you have only those elements of A which are not in common with B. Here, you have only those elements of B which are not in common with A. And here, you have the common elements of A and B. So if you sum these three up, you will get all the elements that are there that are going to be there in A union B. You will get the total count. That is, you'll get the size of the A union B set by summing up these three. Because here you have only the unique elements of A that are not there in B. Here you have the unique elements of B that are not there in A. And here you have the common elements. By summing them up, you get the total elements, the total count of elements that are going to be there in the union set. Does it make sense, guys?
Yes. Yes.
Okay. So far that we've established this, now let's see what the right-hand side equates to. Whether we get the left-hand side from the right-hand side or not. Now, in the right-hand side, we have the count of A, which is what? N1 plus N2, N1 plus N2, plus the count of the elements in B, which is what? N2 plus N3, minus the count of the elements in A intersection B, which is what? N2. Okay. So this gives us what? N1 plus N2 for A, N2 plus N3 for B, and N2 for A intersection B, right? So if we do this, subtract N2 from these summations, then what do we get? N1 plus N2 plus N3. And we've already established that the number of elements in A union B is equivalent to N1 plus N2 plus N3. That is what we got from the right-hand side. So it's equivalent to the count of elements in A union B. All right, that is the proof. And you can use set theory to prove rules in counting as well. So for example, here we are proving the principle of inclusion and exclusion in set theory using just logic. All right, using logic, we are proving the inclusion exclusion principle of two sets. And by doing so, we are also proving the subtraction principle of counting because these are synonymous. Does it make sense, guys?
Yes,
Yes, ma'am.
Okay. Now let's do a problem that utilizes the subtraction rule. Okay. How many bit strings of length 8 start with a 1 or end with 0, 0? We have to count all the bit strings of length 8 that either start with 1 or end with 0, 0. Now, if we had to count an 8-character long bit string, or that is, if we had to construct an 8-character long bit string, then it could either start with 1, right, or end with 0, 0. So you could say that the task of choosing a bit string or creating a bit string that is 8-character long and follows these conditions, you can do that either by creating a bit string or choosing a bit string, either by choosing a bit string that starts with 1 or choosing a bit string that ends with 0, 0. This task of choosing a bit string that is 8-character long can be done by either choosing a bit string that starts with 1 or choosing a bit string that ends with 0, 0. You can make either one of these two choices, right, to do the task. Now, by applying the sum rule, if we say that the total number of bit strings of length 8 which follow these conditions would be the summation of the total number of bit strings of length 8 that start with 1 and the summation summed up with the total number of bit strings that end with 0, 0. If we did that, there would be a problem there. Why? There would be an overcount. Because when you are counting the number of bit strings that start with a 1, you're also counting those bit strings which start with 1 and at the same time end with 0, 0. For example, 1 0 0 0 0 0 0 0 1 0 0 0 0 0 0 0. This bit string starts with 1 and ends with 0, 0 at the same time. So when you're actually counting the number of bit strings which start with a 1, you're counting those bit strings as well. Fine, no problem with that. However, when you're counting the bit strings which end with 0, 0, there as well, you will have some bit strings which both start with 1 and end with 0, 0. This same bit string, the one that I gave you the example of 1 0 0 0 0 0 0 0, that bit string will be there in both of the sets, right? This bit string will be there in the set of bit strings which start with 1 and also in the set of bit strings which end with 0, 0, right, guys?
Yes, miss.
Yeah. So if you basically think of a set A, if you think of a set A which contains all bit strings of length 8 which start with 1, and set B which contains all bit strings of length 8 which end with 0, 0, and if you say that, we'll just add the elements of these two sets together and we'll get the result from there. Where is the error with that? The error is that the bit string which start with 1 and at the same time end with 0, 0, these bit strings will be counted twice. All right? So that's the reason we would have to sum this up and then deduct the common bit strings. That is the bit strings which both start with a 1 and end with 0, 0. These bit strings have to be deducted once because they have been counted here once and then again here. So twice. We cannot have repetition of count like that. That would give us the wrong result. So that count has to be deducted. Okay. So here we will apply the subtraction rule because here we have a task that can be performed in either n1 ways or n2 ways where some of the n1 ways are the same as some of the n2 ways. Because some of the n1 ways are the same as some of the n2 ways, that's why we have to apply the subtraction rule here. Okay. Now, how many bit strings are there of length 8 which start with 1? That is, we are trying to calculate the bit strings in the set A. The bit strings, the number of bit strings in the set A. How many bit strings are there that are of length 8 and start with a 1? Think about that. The first character, the choice for the first character is fixed, right? For the first position, it starts with 1. So at the position of choice fixed, the first position is fixed. That is, the first task can be done in only one way. You can only choose one. So that one is fixed. However, the rest of the 7 positions, for the rest of them, for each of them, you have 2 options. For each of the rest of the 7 positions, you have 2 options. So basically, there are 2 to the power of 7 ways to perform the first task. All right, or there are 2 to the power of 7 possible bit strings which are 8 character long and start with the number 1. Make sense, guys? Have you got 2 to the power of 7 for the elements of A?
Yes, ma'am.
All right. So for B, the same idea. For B, in the set B, we have all those bit strings of length 8 which end with 00. So here, bit number 7 and 8, these two are fixed, right? Bit 7 and 8 will be 0 and 0. For bit 7 and 8, how many options do you have? For each of them, you have just one option. That is, it's already fixed and decided, all right, that bit 7 and 8 will be 0, 0. So what do we have? The rest of the bits, the preceding 6 bits. The preceding 6 bits, for each of those, you have 2 options. So the number of bit strings which are of length 8 and end with 0, 0 would be 2 to the power of 6. Okay. Similarly, A intersection B would have all those bit strings which both start with 1 and end with 0, 0 at the same time. In that case, how many bits in this bit string have a fixed value? 3. The first one and the last 2 are fixed. The first one is fixed to 1 and the last 2 is fixed to 0, 0. These 2 are fixed. And the ones in the middle, the 5 bits in the middle, 2, 3, 4, 5, bit 2, bit 3, bit 4, bit 5, bit 6. These 5 bits in the middle, for each of these bits, we have 2 options. So hence, the number of bits which start with 1 and at the same time also end with 0, 0, such bit strings, the number of such bit strings would be 2 to the power of 5. The total number of bit strings which either start with 1 or end with 0, 0, that is the one that we will have in union, would be 2 to the power of 7 plus 2 to the power of 6 minus 2 to the power of 5. So the principle of inclusion exclusion or the subtraction rule applied here. All right. In order to visualize, you can take a look at this. Here, the first one gives us the number of bit strings that we can have which are 8 characters long and start with a 1. So start with a 1 and 8 characters long. So 1 is fixed. The rest of the 7, each of the rest of the 7 can either be one of 2 bits, right? For each of the rest of the 7, we can choose either one of 2 options. So 2 to the power of 7 here. For the second case, where the last 2 digits is 0, 0, last two bits are 0, 0, these 2 are fixed, all right? So just one choice here, one choice here. And for each of the preceding 6 positions, for each of them, we have 2 choices. For each of them, we can pick any one of 2 choices. So 2 to the power of 6. Finally, here, the bit strings which will have both 1 and 0, 0 at the end. For those, these 3 positions are fixed. And in the middle, the 5 bits in the middle can be any one of 2 bits, each of them. So 2 to the power of 5. So when you are adding these 2, A number tar, these bit strings, when you're adding the count of these bit strings and these bit strings, you're counting these bit strings twice. Because these bit strings, last third bit string A structure ta A definition and A definition pore. So you're counting them twice, so you'd have to deduct this once to get to the correct result. Make sense, guys?
Yes, miss.
Okay. So if it makes sense, then good. The description, the explanation that I gave you, that's here in detail. You can go over this explanation as well. All that we've discussed is just there. All right. Just all of that here. You can go over it later on if at any point you feel confused by this problem, and you can ask me about it. Yeah, so that is how you apply the subtraction rule or the principle of inclusion-exclusion in problems revolving around counting. Okay, you might expect other problems like this as well. So
Yes.
that's, yeah.
Miss, do we have to write explanations like that?
This explanation is this much detailed for your understanding, but it's not necessary that if you're asking the explanation ki amar mukhostho kore okhane likhte hobe kina, obviously not.
লিখতে হবে নাকি? সেভাবে লিখতে গেলে তো ঝামেলা।
Yeah, but you have to explain it to some level, right? Kichu level porjonto to you have to explain it. Je how you got to the power 7 to the power 6 to the power 5. Is eto detail you won't have to explain it, all right? Obviously not. This is here. I wrote it in this much detail so that it's clear to anybody who's confused with this problem, okay? But just by going over the slide. However, if you were given such a problem, then it is not expected that you would give such a long drawn explanation. It is not expected, all right? You can just get it done with a small explanation, a very small description, if needed at all, right? Any other questions regarding this session? Okay, then we can end the session here then.